Students, now we are started new chapter for your competitive classes. That is motion along straight line path. It is the second unit. We are completed first unit, motion along straight line path. This chapter is very easy, but few concepts are required to complete your knowledge level. You know, in this, we calculate everything by an object called point object. What is a point object? Point object is the object for which distance is longer, too much longer than the object. So the point object. And distance, displacement, speed, velocity, acceleration, time. These are parameters for this chapter. You know, distance is the length covered by the object and it is a scalar quantity. Displacement is the vector quantity. Speed again is scalar and velocity is vector quantity. Acceleration is vector quantity, time is scalar. You also know elementary definition of these points, so we don't discuss about it. Only the position of object when we discuss, then there are two positions, rest and motion. In case of rest, the reference point is same, and in this case it is different. It means the object moves about the reference point from one point to another. So these are the elementary points. Now motion along a straight line path can be derived from, there are three ways. In one-dimensional motion, two-dimensional motion, and three-dimensional motion. The one-dimensional motion needs only one axis. It may be it along x-axis or y-axis or z-axis. So we need only one axis for the motion. Then this motion is called one-dimensional. When two axes is required, two axes is required, then it is called two-dimensional motion. And three-dimensional motion require all the three axes. Sometimes it is very difficult to differentiate which type of motion is one-dimensional or two-dimensional. One-dimensional is very easy. As we move along the road or the motion along gravitational path, so that is the one-dimensional motion, that is easy. But two-dimensional motion needs two axes, means length and width. And three-dimensional motion, when all the three axes is required, means x, y, z, just like aeroplane flew in the air. Then it have all the three axes. Okay. Now, there are few facts about speed and velocity, which is some important. Speed may be positive or zero, but never be negative. While velocity positive, negative, or maybe zero. It is very important thing, speed never be negative. The second, the magnitude of speed and velocity is same along a straight line path. Third, the ratio of speed and is equal to or greater than 1. Speed upon velocity greater than or equal to. Now we discuss about some graphs, in which first is the displacement time graph, and I give you the 5 situations here. We study the slope of the graph in each the cases. Here, in the case first, A, slope is parallel to the time axis. It means the velocity is 0. Velocity or speed is 0 along this. In the second, the slope is started not from 0 but above from the 0 point. So its speed is increasing. So it is uniform speed here, or it is moving along positive direction. See, its speed is decreasing uniformly. D, its speed is variable, because sometime it is increasing and sometime it is changing throughout. So it is variable. And also in this case E, it is decreasing and increasing both. Now we discuss about velocity time graph. There are maybe three situations. In the first situation, you say in the A, it is started from the origin. So its initial velocity, in case of A, initial velocity is 0. And it is uniform. Also, it is uniform. In the second case, you look here, the object is moving till some more distant. So, its initial velocity is not 0. It has some initial velocity. So, u is equal to not 0 in this case. And the third, here you look, the velocity is variable. Also you look in any graph, however it is displacement time graph or velocity time graph or acceleration time graph, we get two more things. First, slope. Second, area. If slope of this line, it will give the slope. If we make it another line here, then its angle is θ1 and its is the θ2. And it is very obvious that θ2 is greater than θ1. So speed in this path, in the first path, is greater than the second. It is one thing is important here. So we get the slope, and slope is always measured by this. So slope is the tan theta, and tan theta is here velocity upon time. And rate of change of velocity, you know, it represents acceleration. So here acceleration is increasing, and somewhere it may be decreasing also, but not in this figure. The second thing, area. Area under the flow. It is as you look here, velocity v into t. So area will give, area under the slope will give here the displacement, because velocity into time is the distance or the displacement. So it is the area under the slope. So we study here two things, slope and area. Now we learn some more things. Now we discuss about acceleration time graph. Here, acceleration and time. When you look, it is started from origin. So at origin, its velocity is 0. When object is at origin, its velocity is 0. When it moves for some time, it means also it moves by constant velocity. You look, the slope of curve, slope is how much? You draw perpendicular, then it gives you acceleration upon time. Rate of change of acceleration, but it will give you nothing, because here the acceleration is 0. So the slope will give you 0. In another case, let the graph shows parallel line to the time axis. When the graph shows parallel to time axis, then you find the area under the line. Area is equal to A into T, acceleration into time. You know, acceleration is the rate of change of velocity, so it will give you velocity change. Here it is uniform, steady, so we can say that it is moving by constant velocity. Now we discuss about the equation of motion. The first equation, you look here, v is equal to u plus at, and the second is the s is equal to ut plus half at square, and third one is v square is equal to e square plus 2s, and the fourth is derived from the second, s is equal to nth, the distance covered in nth second. Nth second is given by initial velocity plus half acceleration into 2 times of the t minus 1. These 4 formulas are applicable in number of numerical problems. So we discuss these formulas in those problems. Now look here, we require something more here. Sx, let the function given in the distance form Sx is a0 plus a1t plus a2t square plus a3t. Then how can we calculate the initial position, initial velocity, final velocity, acceleration, all are given from here. And every year, one question must be asked on this basis. So let here, differentiating. With respect to time, then ds upon dt. Here a0 is constant, so it goes to be 0. And we have a1 plus 2a2t plus 3a3t square. Now at t is equal to 0, ds upon dt, that is velocity, is given to you. Here these all functions, all terms should be cancelled and we get only a1. So a1 is the initial velocity, u0. When again differentiated, we get d2s by dt square. It will give you, a1 is now 0 and it is the 2a2, which is the acceleration. It goes to be acceleration. Is clear? So here you look, we use the half at square in this case, and it is always represent the same thing. In all the numerical problems we can compute this way. Now we discuss about motion under gravity. It is also along the straight line path, but now the object is moving opposite to the gravitational field or along the gravitational field. As you know, the gravitation is always towards the center of the earth. So the direction of gravitation is along the center. Now when we are going above from the surface of earth, then this g, gravitational acceleration, must be negative. And when we move downward, then it is positive. Then our formulas changes somewhere. It is u plus minus gt. If plus g when we are moving downward and minus g when we are moving above the. S is equal to ut plus minus half gt square, and third equation v square is u square plus minus 2gh. Now we use h as the, we measure the height. Is it clear? Now today we close the topic, and the numerical problems based on these facts we do in the next period. Thank you.